So section 3.1 is going to work on parabolas. This is going to be our introduction to polynomials. So in general, parabolas are part of that set of polynomials. We'll talk about those in 3.2. There's a lot of things that I could ask for you in this section. Typically, and most importantly, I want you to find the vertex. Now I'm going to show you a couple ways to find the vertex. One good way is if you can put your polynomial that is your parabola into standard form. A times x minus h squared plus k. So if that's true, if you can write it like this, then your vertex is something you can just read off. It's h and k. Beautiful. That's if you get it in this form. Now let's start the process of getting into that form here. Y equals x squared minus 4x plus 3. This is going to require us completing the square. This is old school stuff. I'm going to move the 3 to the other side. Then you might remember this process from your algebra class before this. You take half of the middle coefficient, so half of -4 is -2. And then you're going to square that, and that gives me 4. That's the number I need to complete the square. So I've got y minus 3 equals x squared minus 4x plus something. And that something is the special number I'm going to use to complete the square. In this case, we calculated it as a 4. If you add 4 to the right-hand side, you have to add 4 to the left-hand side. 4 minus 3 is 1. So the left-hand side has y plus 1. The right-hand side will factor as x minus 2 times x minus 2. But I've encouraged you since intermediate algebra to write it as x minus 2 squared, which is really what it is. I can move the 1 to the right-hand side like that. And perfect. Now I've completed the square in this. I put it in my standard form. You can look at this and know, okay, where's the vertex? The vertex is a value of x that's going to make this equal to 0. What value of x is going to make that equal to 0? If I put in
2.
X equals 2, that becomes a 0. All this disappears, leaving me with y equals -1. So you can just read that off of your function when you have it in this form. That's nice. Keep in mind, we've got 2 equivalent forms for this polynomial. This and this are the same. You can use whichever one you want whenever you want. It's just that sometimes one is more convenient than the others. Like for instance, when I find the Y-intercept, if I want to find the Y-intercept, I'm going to set x equal to 0. It's easier to set x equal to 0 here because this term and this term just disappear. What's the Y-intercept of this graph?
3.
3. Perfect. You can just look at it and see it. As far as the X-intercepts, well, you know, those aren't too hard either. You're going to set y equal to 0 and get those. So if I set y equals 0, let's see what happens. I'm going to choose, you can do it here or here. I'm going to choose to do it up here because it looks like that's going to factor. X squared minus 4x plus 3. X minus 1 times x minus 3. And I hope you can read off your X-intercepts. You've got them at 1 and 3. Beautiful. So I know pretty much all the important things to know about this graph just by working with some algebra, not even opening up decimals at all. Now, it's nice to have it in this form because you can just read off the vertex. Let's take a look and see if this matches kind of what we expected here. And let's see, I'll just shut this one off for a moment. Actually shut both of these off. And let's graph it. Y equals x squared minus 4x plus 3. Beautiful. There's my x-intercepts. There's my vertex. There's my y-intercept. Everything that I was looking for. By the way, you can get an extra point for free because there's a line of symmetry that runs through this graph. That's x equals 2. This point here has a symmetric point over here. And that'd be the same y height, just 2 to the right of this line, or in other words, 4 and 3. So if you're graphing this by hand, you can give yourself an extra point. Let's look at another one. In this one, they've already completed the square for you. So we'll use that. And that other one is y equals x squared, or x minus 8 squared minus 5. So I'll write that down here. Y equals 3 times x minus 8 squared minus 5. Can you read off the vertex?
Is it -8, -5?
Very close. What value of x would make this squared term equal to 0?
Oh, 8.
8. And if I put an 8 here, that's 0. Square root of 0 times 3 is still 0. 0 minus 5 would be minus 5. Perfect. So that's the vertex. It's nice to have it in this form. If you were stuck trying to find the y-intercepts, then all right, or excuse me, the x-intercepts, that's going to be some work. Now, before I do that, let's just take a look at the graphs and understand a little progression of things. Here's the graph of y equals x squared right here. Let's see how the graph of y equals x squared is going to compare to the graph of y equals 3x squared. Any predictions on that? Well, let's take a look. By multiplying it by 3, the 3x squared, you're really stretching it or pulling it away from the x-axis. So for instance, at this point, x equals 1, y equals 1. That's in our original graph. But in our new graph, it's been moved up to a height of 3, 1 and 3. That's your point up there. It's been pulled away, stretched by that factor of 3. Let's shut that off. How about this graph? When I turn on y equals 3 times x minus 8 squared, what's that minus 8 going to do to our graph?
Move it to the right by 8.
Excellent. It's going to move it to the right by 8. So let's see that. Perfect. So the vertex that was at 0, 0 is now at 8 and 0. And now there's one last change we're going to make. And that is, I'm going to take this and subtract 5. How is that going to change the graph?
Down by 5.
Down by 5. And you can see our new vertex is something that you could read off of the original graph. In fact, we did. Here's our vertex, 8, -5. Perfect. Well, what if I wanted these points? Well, on decimals, I can just click them and get some approximate values, but those aren't the exact values that sometimes you're asked for. So, all right, well, how do you figure out those? The way to figure out those, the x-intercepts, is you're going to set y equals 0. So it's going to be 0 equals 3 times x minus 8 squared minus 5. Move that to the other side. 5 equals 3 times x minus 8 squared. Divide both sides by 3. And here's where it's easy to make a mistake. You've got to take the square root on both sides. And a lot of people will do that. X minus 8 squared. But they'll forget one important thing. Does anyone see what I've forgotten? Plus or minus. There's 2 of them. There's a positive and a negative root. So it's plus or minus square root of 5/3 equals x minus 8. Move the 8 to the other side. And those are your two values for x. So you've got x minus the square root of 5/3. And I didn't mean to say x. 8 minus the square root of 5/3 and 8 plus the square root of 5/3. And those both go along with 0. It's not very easy. Well, it's not hard, but it's not the smallest of numbers. How would I find the y-intercept? So,
Square zip.
if you set x equal to 0, you're going to get the y-intercept.
Complete the square. I don't know.
Yeah, you don't have to complete the square. We've already completed the square, right? That was done for you when the problem was given to you. So to find the y-intercept, you're going to set x equal to 0. So that's 0 minus 8 is -8. Squared is 64. 3 times 64 is 192. 192 minus 5 should be 187. We should double check that because I was never very good at math. So let's see here.
So can you do it again? I didn't.
Sure.
Thank you.
If you plug in a 0, y equals 3 times 0 minus 8 squared minus 5. That's going to be 3 times -8 squared minus 5, or 3 times 64 minus 5, which is 192 minus 5, which is 187. You can check that the point, the graph does actually cross that point on the y-axis. I'm just going to hold down the shift key so I can change just one of these axes. There you go, the y-axis. Shift and scroll a lot and a lot more, and we're getting close. And I think we should find it. There we go. Beautiful, 0 and 187. Nice. So it's great to have it in this form because you can just look at this and see what the x-intercept is, except you're not always going to be quite so lucky to be given that in that form. So what do you do if you've got something that's not in that form? Let's take a look at example D. These are in the handout for 3.1. So example D is this one here. A lot of things I'm going to be asking you for, but we're going to concentrate on putting this into standard form. So my original function is f of x is 2x squared minus 4x minus 4. The actual algebra for putting this into standard form is kind of a pain. Well, let me remind you of something here. Standard form looks like this. F of x equals a times x minus h squared plus k. Currently, we have it in this form. Ax squared plus bx plus c. I want to point out that these two things are the same. The a here and the a here are the same. And what about the h and k? What do I know about h and k? That's the vertex. Oh, okay. Well, let's be a little bit clever about this then, okay? Let's actually look at this graph. So that's back here. I'll shut this off, turn this one on. If you get a little bit lost in terms of, oh my gosh, this is way bigger than I wanted, you can always hit the home key on Desmos. Brings you back to a more standard window. Can someone tell me what the vertex is of this graph, of this parabola?
One -6.
Perfect. 1, -6. You can just trace on it right there. Thank you. So 1, -6. So our vertex is at 1, -6. That's your H and K. And I know what A is. So A is 2. So that means I can write this as 2 times x minus h squared plus k. And that's going to be a 1 and a -6. Done. All that work that we did for completing the square in the last example got a lot simpler. Now, realistically, I'd probably write this as x minus 1 squared minus 6. The same thing. WebAssign should accept that if you give it to them in that form. But here you go. It was just as easy as figuring out what H and K were and knowing that A is 2. That's great. That gives you standard form, and you can answer questions using this form or this form, whatever you find convenient. If you're asked to find the X-intercepts exactly, not a bad idea to use this. Could be asked for a total of 4 points here, at least by me, X and Y. We already know that the vertex is 1, -6. I guess I would find the Y-intercept using this one. So the Y-intercept, you're going to set x equal to 0. If x equals 0, what do you get for y? Or f of x in this case, f of 0. Right there, -4. And then you can set y equal to 0. Just give me y equals 0. Define the x-intercepts. That you can do here, 0 equals 2 times x minus 1 squared minus 6. Move the 6 to the other side. Divide by 2. Square root. And then move the 1 to the other side. All right, I know that was fast. I didn't really intend to do that part of it here, but you can. You've got everything you could want from this. Minus square root of 3. Those are the 4 critical points that you would need. But what was helpful for us is that we could find the vertex. And we did that with a graph. What if you can't find it based on the graph? What if your parabola is just a big mess and you just can't find it? Well, let me show you one last trick here. And it's going to be in association with problem number H, and this will be our last little thing for today. Problem number H. Let's go down here. There we go. It says find the minimum or maximum value of the function. Well, the function is going to look like this. It's going to be a parabola facing up or a parabola facing down. So that's for y equals a times x minus h squared plus k. What determines if it opens up or down?
The negative in the beginning where the A is.
Perfect. If A is greater than 0, it opens up. If A is less than 0, it opens down. If it opens up, then this is a minimum. If it opens down, this is a maximum. So the problem is not doing you any favors here, not giving you any hints by saying, find the minimum or maximum of this function. Well, okay. We can still do this one though. Let's see what we get. Trying to find a clean piece of paper. There we go. So our function is this. F of x is 6x squared minus 24x minus 170. It would take a little bit of finesse and skill to get this on a graph. 6x squared minus 24x minus 170. It would take a little skill there. But if all we want is the vertex, the x coordinate of that vertex is x equals negative b over 2a. And now I'm assuming that my parabola is in this form. Y equals ax squared plus bx plus c. If it's in that form, that's the x coordinate of my vertex. So let's figure out what that is in this case. That's going to mean x equals negative of something over 2 times something. Here's your A, here's your B. Negative of negative 24 over 2 times 6. 24 over 12 gives me 2. Yay. So that's the x coordinate of my vertex. The y coordinate. How am I going to find the y coordinate of my vertex? I'm not even looking at the graph.
Do you plug in 0 or no?
Perfect. Plug in 2. So if I plug in a 2, I get 24 minus 48 minus 170 should be negative 194. Yay. So overall, my vertex is 2 and negative 194. That gives me a way to write this in standard form. And I didn't even look at the graph. How cool is that? In standard form, I put a 6 out in front. Inside here, I'd put x minus 2. And then outside, I'd put minus 194. And now that's in standard form. So 2 for the price of 1 on that one. Excellent. Excellent. You can get anything and everything from either of these 2 forms. X-intercepts, Y-intercepts, axis of symmetry. Axis of symmetry is always going to be the line that goes through the vertex. It's going to have the equation of x equals something. It's going to be x equals this coordinate. So in this case, x equal negative or x equal positive 1 there for this graph. It's always just going to go through your vertex. That's going to be your axis of symmetry. Whew, well done. Comments or thoughts on that one? Yeah, question, go ahead.
So I didn't get the last part, is the x minus 2. What do you get the x minus 2?
Oh, I'm just putting it into standard form. Remember, standard form of a parabola can be written like this: y equals a times x minus h squared plus k, where a, h, and k are the coordinates of your vertex. And I had the coordinates of my vertex. Here's my h, here's my k. This number out front was my a, so there's my a, there's my h, and there's my k. So I just took that information, I plugged it in. And now that's in standard form, and you and your instructor are both really, really happy about that. Cool.
Thank you.
Anything else on this one? Once you got it here, you're good to go. You can answer all kinds of questions about, the polynomial where it's greater than 0, where it's less than 0, like to the left of negative 0.732 and to the right of 2.732, etc. But it starts with finding the X-intercepts and Y-intercepts and putting it in standard form. Cool. Good luck with this stuff. Let me say goodbye to this recording here.